For any given series, if we denote it with the general format of with an, that is sigma an from 1 to infinity, or in other words a1 plus a2 plus a3 plus up to infinity. Okay, say for example, if we take this one, the series of 1 divided by 2n, which is equal to this one, right? Partial sums are defined like this, right? Now I am going to define the meaning of partial sums, right? Okay, so here what we do is we first say S1 is equal to A1. That means our very first term. And in this specific example, S1 will be equal to half, right? And then we define S2 as the sum of the first two terms, right? These are finite terms. And in the specific example, we have half plus 1 over 4, right? And likewise, we define the sum of these first n terms, right? So here this is a1 plus a2 plus a3. And in this specific example, that will be half plus 1 over 4 plus 1 over 8, right? So now these are called partial sums, right? That is the sum up to this nth term. Now let's take S5. That means the summation up to the first 5 terms. Now these are the things called partial fractions. Okay. And in this specific example, what we have is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, up to 2 to the power 5, because these are the addition of first 5 terms, right? And how about S10? S10 will be the addition of the first 10 terms, right? So here in this specific example, you will add from the first term to the 10th term. Now these are the things you call it, like these are called partial fractions, right? That is the sum up to the nth term. So here when you say nth term, that means we have a finite number of terms, right? And you can see if you write down these values, right? Says 20, that means a1 up to the 20th term, right? And it's 25, that is a1 up to the 25th term, right? And if you compute now in our specific example, you can see these values will be like this, right? 0.0.75, and you can see by like you have to compute them manually. This is 999, and this is also 0.9999 something, and this, like you can see by computing these things for our given specific example these values, right? Now that means the value obtained by this addition of finite terms, right? They will be, now if I will write it close to this term. Now this was 0.5 and this was equal to 0.75. Now I am talking about this specific example, okay? And this will be 0.875, right? And likewise this will be 0.9993 something, right? And this will be 0.99994 likewise, right? So you can see these partial sums converge to a certain value, and in this case it is 1. In other words, for this given specific example, right, the partial sum sequence, okay, that means if we write the values, it will be 0.5, 0.75, 0.87, 0.96, 0.99, 0.999. Likewise, you can see that the partial sum sequence converge to a certain value, and in this case it is equal to 1, right? Now here you have to be careful. In defining the series, we already have a different sequence, which is AN, which we normally denote it by AN. So AN sequence is the sequence that we use to define the series, right? And here AN is equal to 1 over 2, 1 over 2 to the power 2, 1 over 2 to the power 3, likewise, right? That is the 1 over 2 to the power n sequence. But this is a different sequence, okay? This is the sequence of partial sums. And how did we obtain the partial sum? So that means the nth position of this partial sum sequence represents the addition of the first n terms, right? Now these two are two different things, okay? So simply when you have a series, there are basically two sequences that we can extract out. One is the sequence of the terms in this series, right? That is this one. And the other one is the sequence of partial sums, which we obtained by the addition of the first n terms, right? So each and every position of this sequence represents the addition of the first that number of terms. That means if this is n equals 3, this third position represents the addition of first 3 terms, and if this is the 10th position, that represents the addition of the first 10 terms. So these are the two sequences that we can extract out from a given series. And now here you can see that the partial sum sequence converged to a certain value. If that is the case, if the limit of the partial sum is a finite value, then we say that the series converge, or a convergent series, and we represent the summation as the limit of this partial sum, right? Now in this case it was equal to 1, so you can see that it is equal to 1. That means for this specific example, the limit of the partial sum was equal to 1. So we can say that this series converges, and the answer for this series is equal to 1, because this is the limit of the partial sums obtained from this given series, okay? So this is how we define the addition of infinite terms, okay? We define the addition of infinite terms with the help of partial sums. And if this sequence diverges, then we say that the series also diverges. Say for example, let's consider this sequence. Okay, this sequence. Now if ANs are represented like this, then the sequence of such ANs will be equal to this one, and that is equal to, starting from 1, that is -1, +1, -1, +1, and likewise, right? So now if we consider the series of these n terms, right, series of these n terms, that means we should add all these terms, right? It means -1 plus +1 plus -1 plus 1 plus -1, likewise, right? Now see what will happen if we take the partial sums. Then you can see that the partial sums will be like this. Now this is the series that we consider. Partial sums means S1 is the first term, S2 is the addition of the first two terms, and that is -1 plus 1. And S1 is -1 and S2 is -1 plus 1. That is the addition of these two terms. And S3 means the addition of the first three terms, and S4 means the addition of first four terms. So if you compute them carefully, you can see that the sequence of partial sums will be something like this, right? -1 0, -1 0, -1 0. So that is the pattern of the sequence of partial sums in our given series, right? So that's like, remember I said when you have a certain series, there are two sequences that you can extract out. The first sequence is the sequence of the terms that is being used in the series, which is AN, and the other one is the sequence of partial sums, and in this case it was something like this, right, which is a oscillating sequence that runs like that, has only two values interchangeably, right? So at each and every point this sequence will have either -1 or 0, right? So does this sequence converge, or in other words, does it have a limit, right? So what do you think about this one? Remember we did such, like we went over a very similar example when we discussed sequences, right? So due to this oscillating property, like since this sequence oscillates between 0 and -1, I mean interchange between 0 and -1, this cannot converge to a certain specific point. I explained this one in detail in the videos related to the sequence convergence, right? So with that idea, you can say that this sequence of partial sums does not converge, okay? Converge. That means this diverges, right? So according to the relationship between the partial sum and the series, we can say that, like we have defined, if the sequence diverges, then we say that the series also diverges, right? So simply, if we have a series like this and the partial sum sequence like this, not the sequence AN, okay? Now don't get these two things mixed up, right? So here we are considering the sequence of partial sums, right? And if the sequence of partial sums converges, or like now, that means if the limit exists, right? If this sequence converges, that means limit of Sn exists finitely, then we say that the series also converges and the value of the series is equal to that limit of the partial sums, right? And if this sequence diverges, that means this limit is infinity or it does not exist. Both can happen. Then we say that the series diverges and like you cannot have any relationship, right? So then we will say that the series will diverge. Now remember, in this example, the sequence of partial sums did not have a limit, but let's take this one. Now if we take the sequence n, right, this one, and then that will be equal to 1 2 3 4 likewise. And if we construct a series out of this sequence, okay, that means this one, that means we are adding up all the terms in the given sequence, then you can see that the partial sums will be like this, right? S2 will be equal to A1 plus A2, that is 1 plus 2, and that is equal to 3. And S3 is equal to the addition of first 3 terms, which is 1 plus 2 plus 3, and that is equal to 6. Likewise, you can see that the partial sum sequence 1 3 6, likewise it increases to infinity, right? So in this case the limit of the partial sums is equal to infinity, but here it did not exist, right? Anyway, in both these cases we say that the series, the corresponding series diverges, right? And if there is a limit for this one, we say that the series converges and the value of the series is equal to the limit. But in this case we don't say such a thing, we just say that the series diverges, right? Okay.